So what I'm going to try and cover ambitiously in the next half hour are some of these elements. So we'll talk a little bit about BioShare, the project overall, about this environmental project, and look briefly at some of the study cohorts we're including. We'll think a bit about harmonisation and some of the challenges we've faced, similar to the challenges that have been mentioned by Jenny, and I'm sure that you touched upon this morning. We'll think again a little bit about analysis, although I know you've got a session later to look into that. So I'll talk more about the analysis challenges we've faced. And then I'll think, hopefully, recap some of the opportunities and challenges, and maybe some of my thoughts on how we might want to move forwards with cross-cohort research. And I've included some references, so if there's more details that you want, you can hopefully go away and look into those. So BioShare, this is a massive European project. It's a 5-year project, and we are in our final year. This project needs to be finished by the end of this year. And the BioShare, the acronym stands for Biobank Standardisation and Harmonisation for Research Excellence in the European Union. Our mission across the whole project is to facilitate data harmonisation and standardisation, data sharing and pooling across multiple biobanks and data sets. And I've kind of added this why. This isn't the official BioShare why, but this is kind of the main sort of motivation for many of us working on BioShare, is that now for many of the scientific questions that we want to address, no single study, even very big studies like UK Biobank, provide the adequate numbers of subjects that we need and that are measured or assessed at the kind of level of detail that we need or sufficiently well. Therefore, if we can harmonise and standardise our existing cohorts and biobanks in valid and effective ways, we've got this massive pool of people that we can use as our study participants and kind of really tackle these big questions. And who is involved in BioShare? Well, loads of people. There's about 17 different institutes across Europe. So this is a huge project. It's a consortium of cohort people leading the cohort studies, international researchers, epidemiologists, statisticians, software developers, ethical, legal, social implication people as well. And again, there's loads more detail here. The BioShare website, look it up, have a look. There's lots of information on there. It's a massive FP7 funded project. Inevitably, there are a whole host of work packages. The work I'll be talking about falls within work package 7, these environmental and societal factors, but as you can see, there's a lot of other work ongoing. Across those work packages, there are specific projects, and I don't have time to tell you about any of them other than a little bit about our environmental determinants project. So drilling in on that, our aim, very briefly, is to study how environmental exposures affect chronic multifactorial diseases. And the focus, a priori, was always going to be on road traffic noise and air pollution exposure, ideally with harmonised exposure measures, these environmental exposure measures being assigned to participants across multiple cohorts across different countries in Europe. And just to credit, obviously there's hundreds of people involved in BioShare overall, but a lot of the work I'm talking about is work that's been done by our fantastic PhD students on our environmental project, Wilma and Samuel. And Wilma's focusing on the health effect of environmental noise on blood pressure and heart rate, amongst other things. But that's the one that most is aligned with what I'll be telling you about. And Samuel is looking at the effect of road traffic noise and air pollution on cardiorespiratory health. Unfortunately, unlike Jenny, I won't have time to present much of the results, but please look out for the papers that will be published hopefully over the coming year. So these are a few details of our cohorts. In the UK, we've got Epic Oxford and UK Biobank. So we've got nearly 600,000 participants from across the UK. We've then also got 500 participants from from this region of Norway, and then nearly 100,000 participants from Lifelines in the Netherlands, or a specific region of the Netherlands. And these are the cohorts that we're trying to harmonise and work across. So, a few issues with harmonisation. Firstly, we kind of make this distinction between standardisation and harmonisation. Standardisation perhaps would be the ideal, that 2 or more studies have access to, adopt, apply precisely the same protocols, so utterly standardised approach across different cohorts. But what we're tackling more often, and what's been talked about today, is harmonisation. And that implies that these protocols of these different cohorts, these different biobanks might be different, but the information generated is similar enough or carries similar enough meaning that we can try and allow the information after harmonisation to be pooled or analysed and compared. And so I don't subsequently make much of a distinction. I talk more about degrees of harmonisation, but standardisation would be great to move towards if possible. So we had lots of different elements of harmonisation. We had to harmonise our exposure data, our outcome data, and a whole host of covariate data. And the exposure data, there was no exposure data in these cohorts. We wanted environmental exposure data, we wanted information on exposure to road traffic noise and air pollution. Well, those don't exist when you go and ask. Well, they do now exist. If you go to UK Biobank and ask for those data, they exist courtesy of this project. But to add those to each of these 4 cohorts, we needed to develop harmonised or standardised air pollution and noise exposure models that could be applied at the individual address level, so that we could take the address of each participant, really high resolution model, but also apply this across cohorts across Europe. So not only a really high resolution model, but also one that was applicable across many nations. And obviously this is not straightforward. The process you don't really need to know huge amounts about, but even just securing permission to access address level data from a cohort is obviously hugely problematic. Most of these cohorts and biobanks are not set up to give out those kind of confidential information. So that was a huge hurdle, at least initially, to get anonymised address level data so that we could add in the environmental exposures required. Geocoding participant addresses for hundreds of thousands of participants is no mean feat. Then running the exposure models for noise exposure, which is a propagation model, it takes into account 3D building heights and so on. This is a massive, massive undertaking. And yet these models were run and assigned to each participant. And then we returned these exposure data to the cohorts. And so these cohorts now do have these data available for researchers to use. For the air pollution model, and I can't remember who I was talking to earlier, we were talking about the ESCAPE study. This is another FP7 funded project that's now run its course. But as part of this ESCAPE European study of cohorts for air pollution effects, they developed a really nice air pollution land use regression model. And that's what we were able to use for 3 of our 4 cohorts. And this is where we start to see the shaky grounds of harmonisation. But this is a really elegant model. It's been validated for for our cohorts for the UK and the Netherlands, but not for Norway. So we couldn't assign ESCAPE air pollution measures to our Hunt cohort. But this was, and going back to Jenny's point about quality versus coverage, this ESCAPE model was our better model, and so this is the one that we would ideally use. And so we've added to each of the cohorts, to Lifeline's UK Biobank and EPIC Oxford, we've added in these, you can't really read them, but these fields that describe levels of nitrogen dioxide, nitrogen oxides, PM10, PM2.5, and so on. So these data sets have been enriched by adding in these exposure data. Because we needed coverage across our 4 cohorts, not just quality across 3 of our 4 cohorts, we've also added in an additional measure of air pollution of nitrogen dioxide and PM10 from another really good EU-wide model, but one that is not quite so good when looking in at sort of the address level. And this is another model. Oh no, the reference is there, good, I thought that dropped off. So that was able to be applied, although it doesn't show it on here, it was able to be applied also in Norway. So this was our coverage. We covered all of the cohorts with a standardised or harmonised measure, but maybe not the ideal measure that we would have picked otherwise. And then the road traffic noise, as I mentioned, this was an incredibly detailed, complex model. It takes into account traffic flows and sound propagation as sounds bounce off building surfaces and so on. It's based on a modified version of this NOSOS, Common Noise Assessment Methods, which is a European initiative. And again, each participant from each of these cohorts was assigned a variety of measures of noise. Noise is measured as a daytime metric, also evening, overnight, and then a couple other sort of averaged measures as well. So again, these data sets are now enriched because of adding in these data. This took months, if not years, to develop the model, and then even more time to apply it. And we're talking sort of about opportunities of cross-cohort working. This wasn't part of BioShare. This is this NOSOS initiative, but we took this and have developed a user-friendly interface so that anyone who's got the necessary input data could apply our BioShare model to their own cohort data, which is another kind of the opportunities of using these data are that we enrich them. So this is just a summary of the exposures that we were able to assign, these harmonised exposures. But as you can see, the Hunt cohort in Norway didn't have this escape model, but we were able to assign a useful measure of air pollution and noise exposure to each of our cohorts. So that was our exposure harmonisation. We were then left with a similar problem to Jenny, and I'm sure that you maybe discussed this morning, of the really challenging issue of retrospective harmonisation. So where we have these 4 cohorts, they've all collected data on a variety of questionnaires in a variety of different languages, using a variety of different protocols. And we want to somehow massage them all into something that means the same thing, that we could pool those data meaningfully across the cohorts and not just look at the data sets we've got cohort by cohort. And the approach we adopted in BioShare was based on this data shaper approach, and there's a paper here and several others that describe this. And so we needed for each, not just for each project, but for each research question really, you develop a data schema. So you carefully describe the ideal variables you would want to address a specific scientific question. So it's driven from the scientific question approach. What variables would you ideally need to address this question? You then look at the data available to you within the cohorts you've got and develop a harmonisation platform and develop the pairing rules that determine whether or not information collected by each cohort can actually be paired, constructed into these predefined harmonised variables. And if they can, you apply these algorithms so that these pairing rules are kind of run and you end up with your harmonised variables. This is great, but obviously reality hits, and we had 60 variables that we needed, ideally, for our environmental project, but 46 of them were able to be generated in some shape or form. This might, and going back to this iterative process, it might not have been the exact desired variable, but it were able to be created across the cohorts, but 14 just were not able to be created. Anyway, we ended up with many of our target variables that we could then use in our analysis. And so I'll talk about a couple of, not in detail because there's no time, but I'll talk about a couple of the variables we were trying to harmonise. Some of them were really easy. So our outcome variables, each of our cohorts has linkages to, in the UK, the mortality statistics and hospital episode statistics. So our mortality and cohorts elsewhere had similar linkages, all coded via ICD codes. It's a standard diagnostic tool. Yay, these are harmonised, standardised, straightforward. So that was easy. Other endpoints, not so. So blood pressure, systolic and diastolic blood pressure, available in all of our cohorts, fantastic. But of course the measurement protocols vary cohort by cohort. In EPIC Oxford, blood pressure was measured by a general practitioner usually. They took 2 measurements and took the mean. In Hunt, similar-ish protocol, they took 3 measurements and took the mean of the second 2. In Lifelines, in the Netherlands, 10 measurements were made and the last 2 were standardised. And so you're left with this question where we harmonised it. We had a measure of systolic and diastolic blood pressure for each cohort, but are they actually measuring exactly the same thing? So probably harmonised. These were biobanks as well as cohorts, and we had blood biochemistry data for 2 of our cohorts. UK Biobank will have these data, but they didn't when we needed to obtain it. But again, in Hunt in Norway, we had non-fasted blood samples. In Lifelines in the Netherlands, we had fasted blood samples. And for glucose especially, that's a completely different measure. They're not comparable. So again, we're left with this question about how harmonised really these particular variables are. I understand earlier you talked about harmonising body size and socioeconomic resources, so I won't touch on those, and that was kind of self-reported health was also talked about. So I'll cover a couple others, and again, some really easy. Age at interview, very straightforward. It was either directly recorded, or you could use date of interview and date of birth and very easily calculate it. So some harmonised, no problem. Others, really challenging. In Epic Oxford, it was our ideal variable we wanted to have was grams of alcohol consumed per week. That was what we were aiming for. In Epic Oxford, we had grams of alcohol per day, so we could multiply that by 7, very straightforward. In Lifelines, people were asked about how often they drank, and then on those occasions that they did drink, how many glasses. We had to then also add in an element of the standard alcohol content of a drink in the Netherlands to get a kind of serving or grams per week. And again, you're getting left with this issue. This is now incorporating various assumptions, and measuring alcohol anyway can be quite a challenging thing from self-report, but we kind of got some measure for each of the cohorts, and again it wasn't straightforward, and we kind of question how standardised or how harmonised it is. I've put that diet's impossible. It's clearly not. People can work very hard to standardise diet. We weren't able to in our environmental project, but other people are working to harmonise aspects of diet for their study questions. But for us, that was out of bounds. Jenny mentioned keep it simple. Adding in diet was beyond what we were capable of. So I'll touch very briefly upon our analysis. And Jenny, thank you. You raised so many of the points. Jenny mentioned this issue of do we want to do a pooled analysis, do we want a meta-analysis or a comparative analysis? And we are also facing this question. So going back to the ESCAPE study, the model we used for our air pollution, this was a phenomenal study. These are some of the cohorts that they've included, many, many more cohorts than we've been able to include in our BioShare project or in our environmental aspect. But they were only able to look at undertaking a sort of study level meta-analysis, a really robust and valid approach. But there are limits to the meta-analysis approach. It only really exploits the within cohort exposure differentials. You can adjust very appropriately for confounding within each cohort, but your adjustment might differ cohort by cohort, meaning that some of the differences you end up seeing across the cohorts could well be a result of residual confounding. And from an analytic perspective, it can be quite inflexible because you might have to go back to each study and ask for another subgroup analysis or to incorporate another interaction rather than just having the data there and being able to do those sort of exploratory analyses yourself. So what we were hoping to do in BioShare was all of this hard work with the harmonisation was going to be worth it because we would be able to do a pooled analysis at the individual level. We wouldn't do a meta-analysis across cohorts. We would take all of the data and we would pool it and analyse it that way. And we would benefit then from having greater exposure differentials by including data from across these 4 countries and these 3 countries and 4 cohorts. We would have much greater exposure contrasts. We would have greater statistical efficiency and greater statistical power, and much greater flexibility for our exploratory analyses to do those interactions and subgroup analyses. But the harmonisation, I think, comes with this cost, and this pooled analysis comes at the cost of perhaps always working down towards the lowest common denominator. So, and this comes back to the quality versus coverage, that really, although you're adjusting for the same confounders, the same covariates, and looking at the same outcomes and the same exposures across these cohorts, they might not be the highest possible quality confounder data, exposure data, and outcome data that you might be able to achieve by doing a cohort-specific analysis. And so really just that as part of our analysis approach, we'll also be undertaking cohort-specific analyses using the very best available data to aid interpretation. And if our analyses are robust, hopefully we'll see quite similar things across our cohorts. And another kind of new approach that we've been using to facilitate our analysis is using an approach called DataSHIELD, yet another acronym, data aggregation through anonymous summary statistics from harmonized individual level databases. I do not come up with the acronyms, can I just say? But this is it's new and evolving very rapidly, but it's an approach that allows you to analyze the data even where the data custodians might not actually want to share their data. So we don't physically need the data, we just need to virtually access it, and we can do this individual level analysis without ever having the data in the same place at the same time. So the DataSHIELD was developed to provide this kind of solution where perhaps legal or ethical constraints prevent data sharing, so some countries are not able to send data outside of their jurisdiction. And it can sort of facilitate collaborations because the data owners themselves continue to sort of have control over their data. And perhaps rather than having several data sets spread across different countries with different collaborators working on them, there's one set of data that everyone works on, and that kind of maintains, the data's maintained in a central place. It's the same data set always. So that's kind of some of the ideas behind DataSHIELD. I was looking at this, so this isn't one of the papers. I still don't quite, well, so the idea really, so UK Biobank, actually we at Imperial hold the extract. Some cohorts still prefer to just give you this study extract as usual. So we hold an extract of UK Biobank in an Opal server at Imperial College, but the Lifelines data is held in an Opal server in Groningen. And the Hunt data, actually, they also preferred to give us that, so that's also at Imperial. But theoretically, the data could be held in 3 different Opal servers in different countries. And we remotely access the data. We have a DataSHIELD R environment. It's quite a specific R environment. The codes are specifically written so that they're non-disclosive, so that we can never get back any data that would allow us to reconstruct specific elements of any data set. But we can run our descriptive statistics, we can run our regression analyses on this virtually pooled individual level data. So it's a kind of really promising, elegant way of kind of moving forwards with kind of analyses of these kind of cross-cohort cross-cohort projects. Okay. Just a few discussion points really, and some of them have already been touched upon and very elegantly raised by Jenny. Some of the opportunities from cross-cohort working. Well, there's some opportunities and some kind of benefits. So I think via BioShare, we've enriched cohort data with these harmonized fields. These are now available for any researchers to use, and with appropriate metadata, and I think that's what the Closer initiative is sort of also trying to facilitate. You know, this is rich data that other people can then utilize in bigger cohorts, cross cohorts. And that's good. And so the more people harmonize and the more those variables are made available to everyone else, the richer these cohorts get and the more likely it is that they're used in these kind of cross cohort analyses. We've undertaken quite a few proof of principle studies. We've been using new techniques, trying out new approaches, which is quite exciting. That's always a nice way of working. And through doing all of this pioneering work, we've developed quite a lot of knowledge and skills and infrastructure and tools, and people, our PhDs and junior researchers are really benefiting from this really kind of multidisciplinary research environment. And in terms of epidemiology, ultimately I'm an epidemiologist and want some interesting science out of this, which is pending. Our approach has ensured this massive sample size, so we've got hundreds of thousands of people in our study across Europe. It's a far bigger study than's been possible by looking at any single study. It's given us this greater exposure differential, so rather than looking at the narrow range of exposures within the UK, we've managed to enlarge that exposure differential by looking across these different countries. And these, the larger sample size and the greater exposure differential, this comes back to why we're doing all this. These elements are required to assess the kind of risks associated with environmental exposures, especially air pollution, Noise exposure, really important in terms of public health because so many people are affected. These are pervasive exposures. No one's really unexposed. But the risks associated with exposure are really tiny. We're talking about a few % increase in risk. So it's important public health-wise, but very difficult to study because these risks are so small. And this approach allows us to kind of really drill down and study these effects, even including looking within subgroups and so on, because we've got the sample size. Of course, these fantastic opportunities don't come without costs or challenges. Obtaining the cohort data, partly because we needed the individual level address data, but obtaining the data, even if we hadn't needed that, I think, really time-consuming. It's complex, it's non-standard. Different countries have different requirements, even different cohorts within the same country have different requirements. So it's not like you can just develop a study protocol that's applicable to all of the cohort custodian application processes. So that was a hugely time-consuming process. And the harmonisation, again, so much more complicated than you might have initially thought. And even though we had a very elegant escape model, this wasn't able to be applied across all of our cohorts. So we did have to then use a less good measure for air pollution if we wanted to have the complete coverage across the data sets. And there were 14 variables, our target variables, that we just weren't able to harmonise. And so, of course, our individual pooled analysis, there are variables that we would ideally want to adjust for that we will not be able to adjust for. And already touched upon this issue of the harmonisation perhaps being representing the lowest common denominator. So rather than having incredibly rich data on alcohol consumption or self-reported health outcomes from a cohort, if you're trying to massage it all so that it's comparable, you lose some of this really insightful detail, and that maybe actually a meta-analysis with full adjustment within the cohort might offer different insights into the disease processes and so on. So certainly you would want to do sensitivity analyses to check that you've not lost some of the interpretability from the harmonisation and pooling. With respect to our exposure differentials, this is one of the big motivators for us, was pooling these data so that we would get this bigger exposure differential. And what we see here is the pooling that I've hidden, the information from Hunt from Norway. And so the pooling of the Lifelines data and the UK data from Epic Oxford and UK Biobank worked really well. This is kind of what we would expect to see, that we kind of, we had a bigger range than you would have seen in an individual cohort, but there was significant overlap. Norway, on the other hand, is really quiet and clean. Because all of our low exposure data really are coming from Norway, it's difficult really to say that we've increased our exposure differential. We've just added in a cohort that's very different in terms of its exposure. So yeah, it's the exposure differentials were limited within the cohorts, which is why we wanted to pool. But you're now left with this question about whether or not really you can pool when the exposures are so very different, and when it's all based on one cohort. Okay, nearly done. So the analysis, this DataSHIELD approach, it was pioneering. It's very exciting. Code is having to be written for us as we do our analysis, which is fantastic. But that makes it very clunky and problematic, and we kind of move forwards and then realise there isn't the code we need to do certain operations. So that's kind of been a fantastic learning process, but hasn't made things run more easily. And I think, again, alluding to a point Jenny made, we've got this sort of ideal process that we envisage at the start of a project, and then reality. This is how we perhaps envisaged our environmental project running, that we would develop some research objectives that would dictate what study variables we would need. We would then identify potential cohorts that hopefully had most of those variables. We would harmonise them to get our target variables. We would run our DataSHIELD scripts after having a minimal amount of training. We'd undertake our analysis and we'd get some wonderful papers. Of course, reality is just messy, and I think Jenny mentioned it's a really iterative process. Any project is, but any cross-cohort, multinational project, I think, is possibly made worse by this. Nonetheless, we have moved through most of these processes now, and the PhD students are writing up some really, really interesting, really, really challenging and pioneering work. So my last slide, I think, really, how do we move forwards with cross-cohort working? I mean, it's really exciting and promising, so let's continue to pursue the goal. And from my perspective, from environmental epidemiology, it provides the sample sizes we need to assess risk factors for complex diseases. But there's lots of things that if I could have, you would dream for. Further validation of these tools and techniques that inevitably need to be delivered for us to work effectively across cohorts. And probably buy-in from existing and yet to be established cohorts. We kind of need new cohorts coming online that are already primed for harmonisation and standardisation. And obviously the more cohorts that are existing and that want to sort of join, the better. Ideally, if we can have standardisation, so prospectively harmonise the data, that would be perfect, and we might then avoid this lowest common denominator issue so that cohorts are coming online already with kind of the dream variables that will work across cohorts. And from my perspective, ideally, if the data access and application process could also be harmonised so that rather than having to fall foul of every single hurdle at every single cohort data access point, if we could just have one approach that would give access to multiple cohorts, that would be great. Oh, they're not references. There are some. This is obviously, these are just some of the people involved in the environmental project. There are many, many more people involved in BioShare generally, and details of all those people are found online. But these are some of the references, the key references that I mentioned throughout, and there's lots more information about some of these approaches and some of these models available there. Thank you.